All right, here we go. Micro mining overview. This is basically a four-step process so that you don't get lost in details. Here you will find out what we are doing and why. It should also be mentioned that this overall process only includes gold, silver, and palladium. All indicators show that rhodium is present, and in some cases platinum. Once you have this data, then we will in detail move through the next step. One word of warning. To some of you, the terms will confuse you, so keep your dictionary close by. Just for an instance, there is the platinum group. Here is the definition. In chemistry, a group of elements with related properties similar to that of platinum, notably high resistance to chemical activity, particularly oxidation and reaction with acids. The platinum group consists of the elements ruthenium, rhodium, palladium, osmium, iridium, and platinum. So, there is a huge difference when platinum is mentioned versus platinum group. It was discovered early on that when one began breaking down the iron compounds, that precious metals were more visible. Later it was found that gold in a nanoform was magnetic. So gold in a nanoform in nature attaches to magnetic materials or compounds, such as iron or nickel. It is believed that all the nanoprecious metals are magnetic. Number one, changes much of the iron into a known form. In essence, breaks the bonds of the nanogold to the iron compounds. If any one of the known steps are removed, the recovery step will fail. What will be disclosed has been documented, as you will learn by documenting your own tests is most important. Months and months of testing eliminated many other acids and combinations of acids. You will crush the ore to 80 mesh or smaller. This is similar to the size of flour. Then mixing the ore with salicylic acid, water, and alcohol under heat. This will turn the iron compounds into an iron oxide, or specifically iron oxide 3. If your initial ore is brown or green, when it hits this stage, it will be red, and more often than not, you will see metallic yellow particles at this stage. It is not stable as far as I can tell, as when heating the yellow metal in a smelt, the gold goes back to the iron. We're going to filter the first step, weigh, dry, sample, and go into a combination of acetic acid and phosphoric acid for the next step. Here, the removal of the iron oxide will leave us about 80% of the original weight. We will dry, weigh, sample, and ready for the next step. It should be mentioned here that we take about a 7-gram sample at each step. Prior to the first step, the untreated ore, or what we call head ore, is sampled. After you have a button at the last step, you will send all 4 samples in for X or F. In the last video, we will go through how to calculate how much metals are showing and how much was recovered. Also know this, if you live in the city where you have chlorine in your water, this may steal your values in the first 2 steps. Use purified water or distilled. Third step. Number 3, you will learn about fluxes in this step, as we're going to fire the ore next. Here you will learn about collectors. The most common collector is lead. Lead will not collect your nanometals. I should say it will collect platinum, but the process for separating the platinum from the lead known today eliminates the nanoplatinum. I could say that years of testing eliminated lead, copper, iron, and tin for use as a collector, and many combinations of these metals. Iron is not a bad collector. However, iron affects the XRF analysis and is difficult to separate from the precious metals. Nickel is the metal of choice. You can use copper for gold and silver, but it pushes the palladium back into the slag. In a smelt, one uses a selection of fluxes and a collector and runs the temperature up to a minimum of 2200 degrees Fahrenheit, where in time it all melts, and when poured into a cast iron mold and cools, the collector is at the bottom and the glass or slag is on top. After cooling, this can be broken away from the collector, and the button is sent in for XRF along with your powder samples. If done correctly, most of the precious metals will be in the collector. In the smelt, we will add metallic gold, silver, and palladium. As far as I can tell, the metallic elements share electrons or atoms with the nanoelements to create a mature or metallic gold, silver, and palladium, which is then sellable. Could write a book on this as well. One does not get more at the end of the process by adding more metallic metals. There is a formula so far that works. Most often in a 60-gram sample of treated ore, 2 grams of the added metal will produce consistently 1 gram of extra metal. Let us call the added metal seed. In earlier research, I got greedy and added platinum seed as well. Wow, what a disaster. The platinum seed drove all the nanoelements up into the slag, and the platinum did not increase either. So far, we just smile and leave the platinum behind. Once some of you have mastered this, I'm most interested in researching rhodium along with you. Rhodium was left alone in the past for 2 reasons. It is hard to find metallic rhodium, and the scrap refiners in general want large batches of rhodium, such as 50 ounces, in order to process. There are new refining methods of rhodium afoot, which should change this in the future. Nickel has an odd property in that as little as 2 to 3% gold will change the white metal to yellow, and your button should look like this. Darker the yellow, the more gold present. Silver does not do this until maybe over 60%. My research shows that silver is a porous collector for the nano elements. Copper does not give a gold cast until a much higher percentage. Number 4, the last step. Until last, as it is the most tricky step. It is also part of step 3. However, it is done towards the end of the smelt. Generally speaking, about 25 minutes into the smelt, one will notice the smelt begins to smoke. This is the values in the slag smoking off. There are 2 things at play here. One is the addition to the adding electrons via seed, and low-level radiation seems to be also necessary. I should mention that we're using alpha and beta radiation, and gamma is the dangerous one, so we don't use gamma. The second is when DC current is added in a liquid, the cathode, negative, will turn liquid elements into a metal. So long as there is an anode, or positive, in the same liquid, and the liquid conducts electricity. The added benefit of the cathode is hydrogen added to the smelt. After about 3 minutes of zapping in the hot smelt, one should observe the smoking to decrease considerably. If one waits too long after zapping, the values go back into the slag and start smoking again. So then one pours within 10 minutes after the zap, and the temperature is back up again. Your questions will be covered in the coverage of these 4 steps in detail. And by now, you have observed that a special gas furnace is used with an open port at the top so one can zap and not lose temperature. The 2 items shown here are the major expenses. A gas-fired furnace, about $700, and a small welder from China, about $400. It should be mentioned here that while we usually process a pound of ore at a time in the leaching steps, one always assays a 60-gram sample to know what can be recovered from a given ore. Excuse me. You will have to learn what a sulfide ore looks like, as this process does not work on a sulfide ore, which is an ore that contains sulfur. Most ores are oxide ores, which means they've been exposed to water and sunlight for years. You'll learn how I find a good ore. A lot of testing was done initially, and 1 in 10 ores failed. The one was a sulfide ore. So next, we will walk you through each step in detail. Thanks.